Okay, let's start. Yeah, ladies and gentlemen, welcome to our first in-person conference since the beginning of the pandemic. Welcome to our talk, Deepfakes 2.0, how neural networks are changing our world. So we had a lot of technical difficulties right now, but we hope that everything is working right now. So can we start?
Before we start, actually, I just saw one very curious video today on the internet, and I know that it's not really professional, but I just have to share this with you guys, right? Oh, this is us, by the way. Maybe we should talk about us a little bit first. Who are you, Martin?
Yeah, so my name is Martin Furch, and I studied computer sciences, and I'm working for TNG Technology Consulting. It's an IT consulting company based in Munich, Germany. And Thomas?
My name is Thomas Andres. I studied computer sciences as well, and after my studies I also joined TNG. And for the last 7 or 8 years we've been working on innovative prototypes, starting with gesture control, but also advancing to robotics and AI and things like that. And one of the results of our work you will see today. And who's the last?
Yes, my name is Jonas. You might see me on the slide over here. And I studied computer science at TU Munich and started at TNG, I think 3.5 years ago. Since then, I've been doing all kinds of crazy shit, and we're going to be talking about one of those today. But now, as I promised you, I want to show you this very unprofessional video that I found on the internet today. And it's about this guy, not the most recent president, but you might still be shocked what he said. Okay, we don't get any audio. Let me just fix that quickly. Oh yeah, right.
President Trump is a total and complete dipshit.
Can you guys hear that? What do you think about that, Thomas? That's pretty weird, isn't it?
Oh, that's really weird. Huh.
And
I'm quite confused at the moment, and I don't know what to say.
Yeah, just to summarize, so right here we have Obama, right? That's Obama. And we have him in a video saying, wait, let's just rewatch it, all right?
President Trump is a total and complete dipshit.
Oh, yeah. This changes my opinion about this guy.
Yeah, it's weird, right, isn't it? Because this video is from the internet, so it's got to be real, right?
One moment. Please stop here. Are you really sure he said something like that? Really?
Definitely, it's from the internet.
When reading online news articles, you should not only read the headline, you should also read the content. And the same is true for maybe videos? Let's have another look on this.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, Killmonger was right, or Ben Carson is in the sunken place. Or, how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time.
Yeah, this is a dangerous time. So my question to you is, who knows this video already? Okay, at least a few. Very good. So we are totally aware of that deepfakes is a very controversial topic. And why do we speak about that? Yeah, we think like Carl Bergstrom. He said, when a new technology like this comes along, the most dangerous period is when the technology is out there, but the public isn't aware of it. That's when it can be used most effectively. So let's have a look to the agenda. At first, we want to make an introduction into deepfakes. We want to differentiate between different types of faked video material. Then we want to introduce you into the first implementation of deepfakes. It's called Deep Face Lab. After that, we want to show our project to you where we maybe made that in real time. Then we want to talk about fields of application, and last but not least, a conclusion. So, let's start. What we just saw here with the Obama video, this was a Obama lip sync. It's called like this, and how does it work? At first, we have a voice double. He talks like Obama, saying stuff he would never say, at least not in the public address. Based on the audio waveform, this goes into a recurrent neural network, and then it puts out mouth tracking data. Awesome. Then we go into the source video and we copy the best fitting mouths, we retime them, and then you have another video where the mouth tracking, the mouth looks or fits to the new voice of the voice double. This is how it works. And this is just copy and paste. So this is not approved as a real deepfake. So Jonas, let's talk about face swaps.
Yeah, here you can see Martin and myself having a beautiful day in the office back in 2019. And what you can see here, Martin kind of gets my face, I get his. We kind of share things around. And this is what you would typically know as a face swap from apps like Masquerade or Snapchat or such. And what is basically happening here, we have a face tracker that kind of tracks our faces, and then we do what is basically a glorified copy-paste. We take Martin's face in that exact moment and paste it onto my face, facial area, and do the same for him. So we don't really have anything that's deep about this. We don't have a deep neural network. We just copy and paste. So therefore, this is not approved as a deepfake for us. And another example that a couple of you guys might be familiar with, this is from our homeboys in Munich, from the TU Munich, is the real-time face reenactment, also known as face-to-face. And what you can see here is, well, this guy on the right, he's doing some weird facial expressions, and George W. Bush, who also is not president anymore, is doing the same thing. So what is here, what's happening here in the background is we have a parametric face model. So that is a parametric model that encapsulates both the appearance and the shape of the face, as well as facial expressions. And we're going to see the parametric face models in action for both of those faces in just a second. So what this allows you to do is then fit this parametric face model to your source actor and your target actor. And you can see that right here. And then you can take the shape and appearance of your source actor, of your target actor, and the facial expressions of your source actor, and you can merge them into one. And what you can do then is to re-render, and then it looks like somebody is doing some weird facial expressions that he's never done. This is really cool, don't get me wrong, but our big issue with this is all just classical optimization. This has nothing to do with deep learning. We're kind of deep learning nerds over here. So this is sadly not approved as a deepfake for us. So what exactly is a deepfake then?
Yeah, so we did some research, and for the examples we just showed to you, there are papers existing. Everything is described how this stuff works. So we thought the same is true for the real deepfakes. So we did some research, and the only thing we found at first was a forum entry in Reddit. And a guy named Deepfaker, he posted some videos there. And the problem with those videos there was, Thomas, do you want to tell us?
Are you ashamed? Okay. So the problem really was that, yeah, we really had some real deepfakes. They were produced by a deep neural network, and they were working as expected. But the purpose of these videos, or all of these videos actually, was to put their favorite actors into different genres. Let's put it like that. So we then said to Martin that he had to research some videos that we could really show. And he actually found something, right?
Yeah, right. So I saw a lot of deepfake videos and was hard work. And but at least I found something I can show you. Let's have a look at this one. So this is from the movie Superman. Cool, Superman. And yeah, so we can see Amy Adams there, at least on the left side. But on the right side, what's that? It still looks a bit like Amy Adams, but let's scale it up. Let's focus, zoom in. So you can see on the right side, it is a, I would say, Nicolas Cageified version of Amy Adams. Yeah. So the face, not the head, but the face is replaced of Amy Adams, and it still looks okay. The interesting thing here is that this output video is created by a neural network, by artificial intelligence. It's completely different what we saw with the Obama lip sync and the Snapchat masquerade, face replacement, face swap. And so this is approved as a real deepfake, and we want to tell you, we want to show you how this stuff actually works. So we are now hopefully motivated. And now we want to watch a video with Shia LaBeouf. He's a famous actor in Transformers, for example. And let's have a look to this one. And have a look to the face of Shia, please.
Do it! Don't let your dreams be dreams. Yesterday, you said tomorrow. So just do it! Make your dreams come true! Just do it!
So, did you recognize something? There is something wrong with the face right now, right?
So look a bit uglier, doesn't he?
Oh, that's not okay. That's unfair. Okay, so this is a not terrified version of Shia LaBeouf. So this is my face right now, and we created this video within 5 to 6 hours. So what you actually have to do is download Deep Face Lab from GitHub, and then you need a video you want to fake, and you need video material of somebody who gets faked in to the original video. So Thomas, this is Martinified, so we need some video material
from you as well, of course, but also from Shia LaBeouf. So this is the video we got from Martin. So this is our input material here. So as you can see, Martin is fooling around like he would normally do. But in this case, it actually serves a purpose because we need different expressions from Martin. So the facial expression should not always be the same, but he should laugh sometimes, he should cry sometimes, things like that. He should also look into the camera in different directions so that the neural network is then able to see Martin from different angles as well. And we need, of course, the same from Shia LaBeouf. There, fortunately, we already have the video material, namely the scene that you just saw. And given these two different videos, we can now start our data extraction. And this will comprise of different stages. So first one would be to really just split them up into video frames. Then we do a face recognition on all of these frames. And then we extract the face, so then so that is the main feature of the image. And based on that, we also align it so that it is always looking centrally into the camera, which will be important for our neural network. And we can do all of these things with just one neural network, actually. And this is a so-called FaceNet. Most of you have probably already heard of FaceNet because it's the thing that is going on in Windows Hello. So that's the neural network they take in there. FaceNet itself can actually extract face landmarks from the face. So this is what you see, the green dots here. So there are 68 or 72, I already forgot, landmark points within the face, which capture the contour, but also the nose, eyebrows, and so on, and so on, and so on. And based on that, we can then also calculate not only where the face really is, but also the direction of the face, so we can directly extract the alignment. And yeah, the FaceNet algorithm works pretty well, so it's a neural network that is pretty good, and we can have a look at how good it is in the video. So here you can see, in most of the cases, even if Shia LaBeouf is looking into the looking sideways into the wrong direction, it's always detecting the face. There are some errors, so we are still talking about a neural network. Namely that the hand is sometimes recognized as the face, but apart from that, it's looking quite good. The problem with FaceNet, however, is that it's pretty slow. So it takes half a second for just one frame to be processed. So this is far from being real time, and that's also one of the reasons why the Deepfakes Lab implementation does not work in real time, actually.
Right. It's always a matter of post-processing, which takes several hours to train your neural network and then produce your deepfake video.
Yeah, and what you get if we have done all the data extraction is pictures like that. So this is our input material for the neural network. As you can see, the face is always centered in the image. It looks centrally into the camera, and now we can do something magical with neural networks.
Yeah, speaking of neural networks, in our case, the neural network is a so-called autoencoder, and what you can see here is that it consists of two parts, an encoder and a decoder. That's why it's called an autoencoder. And what this does is it takes an image of a face, breaks it down to what is called a latent space representation. And you can think about it as containing information about, for example, the facial expression, the lighting conditions, which direction the face is looking into. And then the decoder part takes that information and recalculates this face image from it. So again, we can do this now for Shia LaBeouf and Martin. We have two faces, so we take two autoencoders. And the specialty here is that those two share one encoder. So we can do the very boring step of taking a Shia LaBeouf, encoding him. We get the facial expressions and everything that's in the latent space. And then if we decode that with Shia LaBeouf's decoder, then we get the same face again. That is pretty boring, so let's have a look at something that is way more fun, and that is when you take the face of Shia LaBeouf, you decode it, or encode it and decode it with Martin's decoder. And then you get something that looks pretty creepy. Creepy because it looks like Martin, but it's actually a deepfake with the facial expression of Shia LaBeouf in this case. And that is how deepfakes work. So we're going to have a look at how exactly a neural network is trained in, for example, Deepfakes Lab, which is the base implementation for training deepfakes. So right here you can see a couple of columns. You can see we have been training for 60,001 iterations. And in the first column, you can see this is, well, the face of Nicolas Cage. We're training a deepfake from Nicolas Cage to Donald Trump. And this is like the extracted faces for Nicolas Cage. And then we train the autoencoder, and in the end, when we take the face of Nicolas Cage, put it through the Nicolas Cage autoencoder, and then we get this in the second column. And the third and fourth column show pretty much the same thing for Donald Trump, which is quite boring. So the final step where we can actually see if the deepfake works is what we see in the last column, and that is when we take the face of Donald Trump, we encode it and decode it with the decoder of Nicolas Cage, and then we get the deepfake. All right, let's have a quick look at what is actually happening under the hood. So why do we do all of this encoder, decoder, autoencoder stuff if it's quite boring? So this actually serves the purpose that we can train those two autoencoders independently, and because they use the same autoencoder, we can then take, the encoder will learn to understand both faces, and we can do this transfer for the deepfake. So what will happen is, let's say, have a look at the Martin side. We take images of Martin, plug them into the encoder, plug them through the Martin decoder, and in the beginning we'll just get something, just some noise image, for example. And with that, we can then calculate a loss function because we want that image to look like the input that we just plugged in. And we can do the same thing on the Shia LaBeouf side, and if we train that for, well, 60,001 iterations, then we'll get something that is pretty good in reproducing Martin's and Shia's face, and that is also capable of doing the deepfake. And that's pretty much it. And now we're going to have a look at a time lapse of a training. And here you can see we start from gray images. That's what the autoencoder produces in the beginning. And pretty quickly, the autoencoder learns to kind of reproduce the rough shapes and features of both faces. So you can see it's pretty rough. It's not too sharp. And right now, the faces are kind of starting to jitter around. So that's basically when the neural networks learns the rotation of the face. And if we skip ahead a couple of more thousands of iterations, you can now see that Martin and also Shia, they're kind of starting to look pissed off every now and then. And that's because the deepfake is now learning to reproduce the facial expressions here. And we're just going to skip ahead a couple of more thousand iterations. And I think it's really funny if you have a look at what the deepfake and the final column do. They kind of look very weird. This might take a while. Training neural networks is a long process.
Yeah. So for the Shia LaBeouf video, we trained, I would say, 4 to 5 hours.
4 to 5 hours, yeah, definitely.
On a machine with 2 NVIDIA 1080 Ti graphic cards, I think.
Yeah,
right.
definitely. So now you can see how it looks after, let's say 60,001 iterations. So you can see the reproduction of the autoencoder looks pretty good on both of those, right? And even the deepfake from Shia to Martin looks pretty good. But if we go from Martin to Shia, then we have like these weird green artifacts in the eyes. It's not really that good yet, so we might have to do some further training here.
Yeah. So, but let's say we trained our autoencoder well enough, then we want to go to the inference workflow. So let's have a look to this one. When we want to do the inference, to apply the neural network to our video, we start with a single video frame. Then we use FaceNet to identify where the face is. And then we put that into the autoencoder. And then from the decoder, we get 2 very important informations. One, we get the suggested face, which fits to the face, to the mimic of the input frame, and a mask. And with this mask, we can merge this one in a final faked video frame. So, and this is how deepfakes are actually working in Deep Face Lab. So, you are here because you want to learn something about deepfakes 2.0. And what was the motivation behind that? At first, we wanted a showcase where you can stand in front of a camera, you get filmed as an actor, and it should work. What actually should work? That your whole head gets replaced, not just the face, the whole head. That was the idea. And this should work in ludicrous speed. And last but not least, we wanted to try to produce some clean code. If you have a neural look into the code of Deep Face Lab, yeah.
It's pretty bad.
you said that right now. Okay, so here we have a overview of all the parts we just replaced. And Thomas wants to start, I think, with the face recognition and face extraction.
Yeah, because now we need to replace things from this overview. And the first thing is we want to have real-time implementation, so therefore FaceNet does not work anymore. We need something different. And the first thing to replace here is actually the face recognition itself. There are tons of face recognition software. There's tons of face recognition software out there, so we can just choose some implementation here. And for the Deepfakes 2.0 implementation, we had an interesting approach, I would say, and this was based on OpenCV, so the computer vision library. So what probably not all of you have heard is that OpenCV has an experimental branch called DNN, and with that you can also do some inference on neural networks with OpenCV on the CPU actually. And you can just load a model file, so this is basically a TensorFlow model file and also a config file, and based on these 2 files you can then produce some face recognition results. And here's what the code looks like actually. You can just call readnet from TensorFlow, and then you pass in the model file, the config file, and this is all you need to load the model. Then you need to transfer your image into a blob that is capable of being passed into this network. Then you do a fast forward, and a feed forward, and then At position 0, 0, there will be your face candidates actually. So this will be the rectangles that you need for face detection. And that's basically it. And with this, you can already do the face recognition. Now, let's have a look at a demo now. And hopefully this will work because...
Yeah, fingers crossed. Yeah!
It's
Awesome,
working pretty
awesome.
fine. Okay, so
Yeah.
now you
so
can
the
see.
light condition is not the very best, so is it okay? Yeah. Okay. So at least it's a very slow It's a very slow laptop, but at least you can see it's nearly real time. So we have our desktop PC here, and after our talk, we want to show you the current implementation, and this thing is powerful enough. So yeah. Okay. So this is how it works.
It recognizes faces even if Martin is looking to the side, even if he has his hand in front of his face, but also multiple head recognition is also possible. So this is working pretty well. Okay, problem solved, and it's also real time, so this serves our needs.
It's real time, but not on this laptop.
Next one would be we now need to extract not only the face, but also the whole head. So the FaceNet approach that Deepfakes Lab was using does not work anymore. So what we need now is more like we need to extract or mark every pixel that is part of the face with a specific color, which is called segmentation, so that the neural network knows which parts of the image belong to the face and which to the head, and which ones do not belong to the head. And for this, we trained our own implementation of a neural network, and this one, can you please switch?
Yep.
Thank you. This one looks a bit like this. So we have two neural networks actually. One is called MobileNet, which is a fast neural network, but it is used for classification. So given a picture of a duck, it can say that this is a duck, or this is a dog, or this is a cat, things like that. So this does not help us at all. But we can just cut away the last layers of this neural network and put another neural network at the end of this, and this one is called a UNet. And UNet is also a neural network which is known to be fast, but at the same time it can be used for segmentation. So given now this combined neural network, we can now do a segmentation on an image. And the good thing about this is that MobileNet is already trained. So we just need to train the UNet given one input to output a correct segmentation. So this is also called transfer learning. We do not need to know everything about the environment. The MobileNet already knows a lot of things about the environment. We just need to know the specific task, and this reduces the number of images we need significantly. If we just do the segmentation from scratch and do not initialize our neural network, we will take hundreds of thousands of images or millions of images which are segmented. This way we just need a few thousand actually. And yeah, we can now put all this together, do the learning, and then we can do our segmentation. The only thing that's problematic here is that we still need some images. And therefore we used data set, which is called Celeb
A Mask HQ.
Yeah, like that. And this is a data set of 30,000 celebrities' photos. And for each of these celebrities' photos, there was one guy who really, by hand, segmented the image. So he said, "This is the head, this
head,
is
hair,
eyes,
earrings, clothes, everything."
Yeah, and with this information, we could easily do the segmentation because we had now enough material to train on. And now let's have a look at the result. So what you can see here is Martin again.
Yeah, okay.
Yeah, he looks into the camera, and you can see he looks a bit smurfish right now. So everything that's blue is recognized as his head, and everything else is not. And with this information, we can now do our training based on the whole head. Yeah, so we basically did this, and Jonas will tell us how we did it.
No.
Oh, we have another one. Sorry.
Yeah, because now we want to replace the mask and mask blending thing. So, as you already learned, now we have segmented the whole head. So now we just can say, let's place the fake head on the segmented area and that's it. But there was a problem. Here you can see Thomas' head should be placed on my head. And something obscure happens here, and you can see it here. We have an overlay problem. So we see parts of the old head which should get erased, but yeah. So how did we solve this problem? Now again, we used OpenCV, and there is a function, it's called image inpainting. So the original idea of using image inpainting was, for example, to restore old photographs. There are some scratches in it and stuff. And our idea was maybe we can use this function to erase my head, and then we can place, for example, Thomas' head on it. And again, we have a short source code example how you can do image inpainting in OpenCV. It's really complicated, as you can see. You just call the function inpaint, and the only thing you need is the input image, obviously the image where my head is still in. Then you have the full image mask, so actually the fragmented head area we already have. And then you just say which type of inpainting method you want. There are two existing. Here we are using inpoint telea, which means, let's have a look to the demo and then you have an idea how it looks like.
So, you know, you can see that Martin's biggest mistake is erased, actually. And it works pretty well. And you can do this with multiple faces again, and it's working in real time, like all the other things before. So this is pretty nice. And
what actually is happening is that from the segmented head area, the pixels, they will, how to say that, flow in the inner of my head. So it actually looks a bit like that my head gets actually erased from the video, but it doesn't look perfect. That's clear. But we are only talking about the edges we want to refine somehow, and so this problem was also solved somehow. Let's stop the demo and now let's go to the autoencoder. Jonas.
Yeah, so we've basically talked about everything now that is not involving a neural network, or not the neural network that we actually care about, or at least I do. And that's the autoencoder. So now we have a couple of tasks that we want to kind of fulfill. We want the deepfake to work for basically any face that stands in front of the camera. So we don't want to train for every single pair of faces that we want to deepfake. And also, we kind of want to have more than just one face that we can give people. And we solved both of those problems with this beautiful invention that we call the Multi Decoder. And the idea is, well, it's kind of simple. We just take a couple more decoders. And this allows us to now train a Martin, a Shire, a Drakenlord, a Trump. And the interesting part here is that because the encoder now sees so many different faces, it kind of learns to generalize a little bit better and to apply a deepfake to basically whichever face stands in front of the camera. And at the same time, we can now train a lot of faces at the same time. It just takes ages. And we did that. And then we found out, well, it's kind of not that easy because we got some very interesting results. So if you thought that Martin couldn't get any spookier, here's Martin with an eye on his forehead. And then we have, like, I don't know, some kind of weird Picasso paintings. This one is great. This two-mouth Trump. Yeah, I don't even know what this is. Here we have man, bear, pig. And yeah, I think this is like alien Obama. So the issue that we had here was that the neural network had to now reproduce not only a face area but the entire head and do all of those other things that we just talked about. And this was just like too hard of a task. So we kind of had to think about a way that we could support the neural network in learning how to do deepfakes. And we decided to use a GAN approach. And what exactly is a GAN approach, Martin?
Yeah, the GAN approach, GAN means Generative Adversarial Network, and the idea is that we have a autoencoder, the generator, and on the other side a discriminator. So the autoencoder, the generator, produces some artificial heads, and they are presented to the discriminator. So the discriminator sometimes gets also some real faces, some real heads, real photographs. And the discriminator has to decide which one is fake and which one is real. So actually, there is a fight between the generator and the discriminator.
Fight.
Yeah, okay, ladies and gentlemen, so how to, we're always thinking, how can we teach people about neural networks, how do they work and everything. And our idea is, we want to make an offline roleplay game right now with you. And so we need some roles, and at first we start with Thomas. Thomas is the referee, right? Yeah. The moderator, right?
Yes, I'll be the referee.
Okay, so can you describe how we want to do that right now?
Yeah, okay. So first we need two different people. So Martin, are you going to be the generator?
I'm the generator.
Okay, perfect.
Okay.
And Jonas, you are going to be the discriminator.
Yes.
Yeah.
So to start, we really need the discriminator to look into the other direction, close your eyes, shut your ears, and okay, that's perfect. All right, so now I have something for you, Martin.
Round one. Fight.
So here you can see a face. Have you seen a face or this one before?
I have never seen any face. I'm a completely initialized new neural network. My weights and biases are chaotic.
Okay, so all you have to do is to recreate this face.
Okay. What is a face? Oh, okay.
Yeah, just go ahead.
Okay, okay.
Just start.
Let's try it.
You'll do it.
So, as I don't have any idea where to start, as I said, I'm completely newly initialized. So I start with something like that. And hopefully this is enough. So I would say, dear discriminator, I'm ready.
Okay, discriminator,
Yes.
have a look at these two pictures. So,
All right.
as you can see, or as you cannot see maybe, there is one picture which was painted by the generator.
Oh, really?
And one that was real. So, as you can see, these are both faces.
What's a face?
Okay, again, just try to guess which one is the real one.
Well, that's tough. I've literally never seen anything. Kind of all my weights and biases, they're all over the place. They're basically random. Geez, they look exactly the same to me at the moment, so I don't know. I'm just going to randomly choose the left one, say that one's real.
Okay, let's do this. And the right one. It's the right one.
Yeah, I said the left one.
The-
That's unfortunate.
So, what do you learn from this experience?
Well, looking at now, knowing that the right one is the real one, kind of seems to have like, I don't know, connected lines and such. So I think I might just look out for that next time.
Okay, generator, you heard the man? Okay, okay. Discriminator, you can go into your corner again.
Damn.
Okay, Martin, now that you have learned something, we can go to round two.
Round two. Fight!
The challenge here is basically exactly the same as before, but now you should know what a face is.
Yes, so I heard something about from what, connected lines and so on. I can try whatever that means, but holy shit. I think I'm ready.
Discriminator, here's your task again. Same thing as before.
Beautiful. First off, I have to say they're both beautiful pictures. It's a tough one. It's a tough one, really, isn't it? But I kind of remember that the real one also had like some color in it last time. So I think I might just go for the left one. I think that one's the real one.
Okay, let's check that in. And you were right.
Yes.
So for the next one, we did not, so we could do this for hours or days or even months, but we will not do this, thankfully.
We'll just skip ahead a couple.
But we'll skip ahead for a few thousand iterations, and we let Martin draw a picture of the last phase in advance.
Round 3. Fight!
So that looks a bit different than before, right?
Man, you guys are so tough on me. Like the pictures look exactly the same to me. I don't know. Like I literally cannot decide. I'll just slightly randomly say the left one's the real one, right?
Yeah, we did. We can abort at this place because you cannot distinguish them anymore, and that's when the training ends. And this is how GANs work. But let's recap that a little bit. Jonas.
Yeah, let's recap. So you remember we had images of the real face, and we have the generator, which in our case is the autoencoder, and that's going to generate, well, a deepfake that looks something like this, and we're going to feed both of those images to the discriminator. And we're going to train the discriminator to correctly identify the real and the fake images, and at the same time, we're going to train the generator to create deepfakes that the discriminator will classify as real. So this way we kind of have like a cat and mouse game, like a zero-sum game that is going to start from the very bottom, kind of like college football, and just work its way up to the top, basically, where you cannot distinguish the real from the fake thing. And this is how GANs work, and it's amazing. And we're just going to show you what we can do with this. We can now train deepfakes that don't look like man, bear, pig, because they look like me. And obviously, the lighting is not the best right now. Thomas, do you maybe want to do us the favor of being me so I can talk about...
Okay. What do I have to do?
Yeah, just...
Oh,
Jesus Christ.
The glasses, please.
Maybe I can just light.
Yeah, just take the camera with you. Yeah. So you can see the lighting is less than ideal, but you get the deal of him being me. Obviously, a bit creepy. But anyways, what we can now do is we can take this trained neural network, can generate a deepfake of the entire face on, for example, Thomas, who the network has never seen before. And that is exactly what we wanted to achieve. And now we can switch faces.
The light condition is not the very best one, so
No,
this is
definitely
the
not.
reason for the disturbances here.
Yeah, I'll have a look and see.
I just prepared to my mobile phone, so let's enable maybe the flashlight. So.
Give me some light.
Doesn't really change anything. So let's just go through a couple of faces here. We brought a couple of them with us. Yeah, now you can see Thomas is supposed to be a woman, looks like an alien still, but we're just gonna switch through a couple more faces. Geh mal ganz vor den genau. Yeah, right now Thomas is black. Can we have another face, please? And right now Thomas is old. So you can see you can basically have any identity that you want, really. And that is something that might be very interesting for the future, isn't it, Martin? Let's talk about a little bit of fields of application.
Yeah.
Maybe we should also say the real demo, so the newest one, is gonna be.
Right.
We're gonna show it at the end of the demo, and this was a bit better than what we saw.
Right. So let's have a look to the fields of application. So if we have a look to this movie scene, One is created with the typical approach in Hollywood with CGI effects. And one sequence is generated by a deep fake. So the question is, which one is which one is which? So 3, 2, 1, and let's solve that. The bottom part is deepfake generated. So you may ask yourself, what's the difference? Yeah, I would say at least several hundred thousands of US dollars, because deepfakes are really cheap. You just need some a few graphic cards, some calculation power, and that's it, and some energy. Of course, fake news are misused for fake news generation. That's clear. For scams, for hoaxes, for whatever. But let's talk about the Jan approach again. Jans can bust those fake news. They can identify faked video material. But the problem is, it's a, how do you say in English, cat and dog game?
Cat and mouse.
Or cat and mouse. It's a cat and mouse game. So, yeah. And of course, there is a legal gray area, at least in some parts of the world. And for example, in California, at least when the election was, it was forbidden to use deepfakes in this case. Yeah, there is another example where you can use deepfake technology. Thomas?
And this one is called living portraits. So this combines actually two different types of AI. One is a so-called style transfer, where you can train a neural network to adapt to the style of a work of art. And the second one is deepfakes, of course. And if we combine this in a suitable manner, then we can really have pictures that speak to you in a different way than pictures normally speak to you. So this is kind of the Harry Potter approach to AI. And this is really working out quite well. It works with different works of arts from different ages. Yeah, it's a nice approach, and it combines everything that we've done within the last few years.
Yeah, right. So if you are interested into an introduction how neural networks are generating art, how do they work, how do they recognize graphic, yeah, feel invited to use this QR code to get forwarded to another talk of us, and expect a cool introduction into neural networks and art. So now at this point our talk is finished, and thankfully we have some few minutes time to show you the current state of the art and our current implementation of real-time deepfakes, and I hope that it will work well with this light condition right now. So let's have a try. Okay? Cool. So
in the meantime, if there's any kind of questions, feel free to ask
right.
them, and we'll try to answer them as... Does it work? Is it working? No?
Doch, doch.
Okay, cool. Any questions?
Vielleicht das
from you
Mikro
guys?
weghalten. Ja. Yes, he hired them. Yeah, yeah. He was hired by Hollywood, right? By Lucasfilm, right? Yeah, mach genau, right. So, are there any questions? Oh, there is a question there, please. Can the person in front of the camera put the microphone?
Yeah, that is currently... so
the
question
sorry,
was...
we have to repeat the question for the remote audience and stuff. What about a person who's eating something? Can you fake that as well?
Yeah, so that is currently one of the big issues that we still have. That is occlusion, so basically anything that's in front of the face. Our current solution to that is simply avoiding these situations, but there's definitely some approaches that will, for example, segment out any kind of occlusion, use attention-based mechanisms to, for example, get even better results in masking out everything that is a conclusion and ignoring that. But as of now, this is currently not... Who am I? It's kind of nasty because I can't really look, because every single time okay, who am I now? Who's that?
I think this is a person where we at least have the permission to train the neural network.
I'm not sure. No. Any more questions? Yes, down there. No, you can automate that. So obviously you're going to have your data set of real faces, right? And then the fake ones, those are the ones that come out of your autoencoder. So the question was, again, how do you how do you know for the GAN which pictures are the real ones and which ones are the fake? Any more questions? Yeah, down there.
Actually, this is a huge limitation for those real-time deepfakes. So there are several. Can you please hold that? There are several things how you or signs you can where you can identify a deepfake. Ah, okay. Hi. What is my name? I don't know. So you can have a look to the head edges, for example, if there are smooth, if there are some distortions, also in the face. What else do we have? Unnatural eye movement. The emotion, the mimic, for example, could also be a little bit flatter than expected. Especially if you are speaking with a person you know very well. And there are different signs to spot deepfakes. Also when it comes to suspicious behavior, for example.
Yeah, but specifically about the eyes, that's also a limitation, one of many with deepfakes, because the approach really is that simple, that you take a data set of faces, you just kind of toss them into your training algorithm, and then it just kind of magically gives you this deepfake, right? And there's literally nothing in there that ensures that your eyes look kind of correct or whatever. So those are kind of the things. This is the process that has been going on over the last year or so for us to kind of iron out all these problems that we have, adding additional loss functions for the eyes, for example, and doing all of that and developing the deepfakes even further and further and further.
Yeah.
Any more questions? Oh, Jesus. Ah, right. Good question. Can we unlock phones with this? We actually don't know. I think most face unlock software solutions are kind of reliant on like a depth camera or something like that. You can't really fool that with a deepfake. What we've seen though is that we've done an experiment with like a German TV show where we just would join a Zoom conversation as somebody else and nobody would notice. And we even called their parents and they only noticed after 5 minutes because they were talking smack all the time. So that works quite well for automatic person identification. It's quite a challenge. Oh, yeah. Yeah, great for students. Don't use that for exams. No. Okay. All right. Just down there. Yeah. Right. So the question was, what are our thoughts on basically ethics about misuse and actual good uses of this technology? So yes, we do. Jesus. Yes, we do know that deepfakes can be used for quite a lot of stuff. For that reason, we decided to not open source the code for our project because we basically give you or anybody the tool to basically do all kinds of weird things. But you're completely right. This is also a tool that's kind of maturing more and more to be used by creatives to do film work, to do basically any kinds of things, as they did, for example, for Star Wars. So this is kind of a neat trend that we're observing over the last couple of years, that is how AI is kind of becoming just one tool in the toolbox of creatives. The question was how many faces can we process at once? So there's no limitation on that really. Right now we're just using one because that runs in real time in 1080p at 30 FPS on that machine. Okay, question in the back. So the question was, who's generally better, generator or discriminator? That really depends on, oh Jesus, that really depends on your training setup. In most cases, the discriminator has the way easier part, right? Because you only have to say whether something is real or fake. And actually creating a face is the harder part. So in most cases, the discriminator has a clear edge of the generator.
So.
Yeah, that is a very interesting question. If there's any heuristics on, for example, connecting the neck to the face, or just all the, I guess, all the problems that we're having right now to remove those. We've experimented with a couple of things. For example, a neural merger. So that's a neural network that is going to take the generated face and the actual face and kind of try to merge that into one. Again, trained with a gun, trying to generate something that's realistic. However, that didn't work, because then it would, for example, start creating basically random hair on Angela Merkel, for example, in the face, which is... Yeah, there are definitely some approaches to that, to not doing that with neural networks. It's a tough one, though. All the way in the back. Yeah. Yeah, definitely. So the glasses, that's a fun topic, while Thomas is Bobley had Putin. So that's the thing about just having a neural network, that you just provide with data and then it maybe works or not. And glasses is a beautiful example for that, because if we have a data set of people wearing glasses, then the deepfake is also going to have glasses. If we have a data set of people without glasses, then the people are not going to have glasses as well. If we now have a mixed data set, for example, if Thomas wearing glasses or not, and him not wearing glasses, then the deepfake will kind of learn to identify whether a person wears glasses or not. And depending on that, Jesus, depending on that, giving the deepfake glasses or not. So that's quite cool. If we have data of the person both wearing glasses and not wearing glasses, then the deepfake is going to decide for you. And if we don't, then it's just going to do whatever. And then you can just hold it. It's way quicker.
Maybe this was accidental, but when you on glasses, much better.
Okay, I have no idea what's going on there. That's the fun part about deepfakes. In most cases, it just literally breaks when you have glasses that don't really look like eyes.
Maybe you've seen the Angela Merkel deepfake. So whenever Thomas was smiling, the neural network didn't know what to do, because in the... Yeah, okay. You know the answer, so I can stop speaking, yeah, right?
All right, question there at the door. Yeah. So the question was, how do we deal with beards and caps and all those kind of things? So what's happening right now, the segmentation does not segment for any kind of headwear. So if you have like a cap on, it's just going to cut off your head right there, which is pretty fun. And with beards, that's going to be segmented as a face. And one shortcoming that we have at the moment is still that the neural network, the deepfake, will kind of try to morph your facial features into the deepfake. So the beard will still be there in the deepfake in most cases. So if it's like a long beard, that will still be there, but it might just be a little bit shorter. So that's quite interesting. Yes, question down here. We can do that. We have.
We're faking Jonas with Jonas.
It kind of looks. So the question was, can you just deepfake a person with his own face? And the answer is yes, you can do that. And it just looks underwhelmingly boring. So there's literally. The cool thing though is that I noticed when I wrote this back in spring. So you can literally just train a deepfake of you looking rather decent, and then just use that deepfake to join your video conferences on days where you're too lazy to shower. Yeah. Or you're just absolutely hammered from last night. That also works. Any more questions? Okay. Flannel shirt in the back. Yes. Yeah, that is correct. So the question was about hardware requirements. So one interesting thing that we learned yesterday actually was that obviously the laptop that I have is too weak for the deepfake, so it doesn't work on that. So that machine, as I said, the required or the recommended hardware specs, that's a 2080 Ti in there. So GPU is king. And we also ran this on a 3090. That's when we get the best results. Basically runs on any semi-decent GPU that has, I think, more than 8 gigs of RAM. Below
Yeah.
that, it will just like give you some weird CUDA errors and
Yeah,
run like shit.
Actually, it kind of also depends on the number of deepfakes that you want to load. I got it to work on this machine. It's a Dell Precision 5500, something like that, with a Quadro GPU. You definitely need a good GPU, but this one has 1 gig of RAM or 3 gigs of RAM, something like that.
Yeah.
So it will work to some degree, but it will not be real time. And this is also the problem. Our limitations are basically based on the hardware. So if you want to have 5 faces at the same time deepfaked, then you will need some quite capable hardware.
All right, any more questions? Yeah, they're in the middle. So the question was, is it possible to create a deepfake that cannot be recognized by any kind of algorithm? And the answer is technically yes. So depends on your algorithm, really. So the big issue that you have, and we only touched on this briefly in the talk, deepfake detection is kind of this hen and egg problem where you need a deepfake in order to train a classifier on that, which also means if you have a novel deepfake such as we do, and you have no model that is trained on that, then this model is not going to recognize it. So from a technical perspective, we're also working on things like upping the resolution, making everything sharper, making the merge smoother, making the inpainting better, making everything faster. So at some point we might reach the stage where you cannot, not technically, not humanly, distinguish a deepfake from a real thing. The only thing that you can then rely on is to be kind of skeptical about what you see. If it makes sense that there's Putin at a conference talking about deepfakes, whether that makes sense. So you kind of have to apply the same kind of critical thinking that you would apply to like a magazine cover where you have Photoshop and you know that this is happening, to videos from now on, or even live streams. Okay. Question in the door. The question was, are there algorithms to detect this? The answer is, there are a couple of them.
Let me take this question.
Yeah, Thomas.
So there are a couple of algorithms to detect currently known deepfakes. They rely on different techniques like the eye movement, or also the reflection of light on the eye, or other things. So there's a lot of different techniques that you can use, and there's already one algorithm where you can just upload a video and see if it is a deepfake using these different techniques, and based on that it will give you an error margin whether this is real or not. And this is called deepfake-o-meter. So
yeah. And I think we'll do one more question, and then if you have further questions, we'll just be hanging out here for a couple of minutes. So just feel free to speak to us. All right, last question.
Would like the natural progression now be like for the deepfake 3.0, just swap out entire humans?
That's an interesting question, because the question was, would the natural progression be to swap out entire humans? And there's papers doing exactly what you're saying, not in real time yet, not in such a visual fidelity as we have here with the deepfakes. But that would definitely be like the king discipline, just swapping out entire humans. The issues that you have with deepfakes right now being that something has to be believable, the voice has to kind of fit the face and the movement style and such, that will still apply to that. But that's definitely something that's being worked on. However, it's questionable how much of an extra benefit that's going to have over any kind of deepfake. All right, then thank you very much for your attention.
Thank you
It
very
was
much.
great.
Thank you.